In this lesson, we're going to revisit the 45, 45, 90 and 30, 60, 90 triangles from the previous lesson and show how we can relate that to our sine, cosine, and tangent definitions for trigonometry. This will give us an alternate way of solving problems involving these types of triangles. So if I recollect from the previous lesson, if I have a 45, 45, 90 triangle, so this is 45, this is also 45, one of the patterns on them is that I could put a 2 here, and this is root 2, and this is root 2. These were all times a. So I can use this to determine the sine and cosine and tangent of 45 degrees. I just labeled this triangle for trig. Normally when we want to get the sine or cosine and tangent of an angle, we would use the calculator. Just bring up my calculator and ask it. This will enable us to get a different way of getting the sine, cosine, and tangent for specific angles. In this case, we're going to be able to get it for 45 and for 30 and for 60. So if I label this triangle for trig, this is hypotenuse, this is adjacent, this is opposite. So going through my trigonometric definitions, I'll get sine 45 is opposite over hypotenuse. So the sine of 45 degrees is the opposite, which is a times the square root of 2, divided by the hypotenuse, which is 2a. The a's here divide away, and so I get the square root of 2 over 2. So this is the exact value of the sine of 45 degrees. It's the square root of 2 divided by 2. On your calculator, it's going to look like it's some decimal that you wouldn't necessarily recognize it as being this specific value. The cosine, 45 degrees, actually is the same value. It's adjacent over hypotenuse, a root 2 over 2a, and that's the same. The square root of 2 divided by 2. There's the cosine of 45 degrees. And the tangent of 45 degrees, opposite over adjacent, but those are the same. Opposite is a root 2, adjacent is a root 2, and anything divided by itself is just 1. So I have sine root 2 over 2, cosine 45 degrees, square root of 2 over 2, tangent 45 degrees is 1. Let's see what we can get from the 30, 60, 90 triangle. So the template for a 30, 60, 90 triangle, 60 degrees here, is this was 2a, the short side was a, and this remaining side was a root 3. So if I label this for trigonometry, hypotenuse, adjacent, opposite, we have sine of 60 degrees is opposite over hypotenuse, a square root 3 over 2a. Those divide away the a's, and I get square root 3 over 2. Oops. Cosine 60 degrees is adjacent over hypotenuse, a divided by 2a. The a's divide away, and I just have 1/2. And tangent 60 degrees is opposite over adjacent, a square root 3 divided by a. Those divide away, we just end up with the square root of 3. We can also get the sine, cosine, and tangent of 30 degrees. It's the same shaped triangle, but now I'm going to use my 30-degree angle to set up my trigonometry. So let me rewrite the values in from above. Same three values. Hypotenuse. But now, since I'm focusing on 30 degrees for labeling my triangle, this side over here becomes adjacent. This side becomes opposite. And this enables me to figure out what the sine, cosine, and tangent of 30 degrees are. Sine 30 is opposite over hypotenuse, a over 2a, just 1/2. Cosine 30 degrees, adjacent over hypotenuse, a square root 3 over 2a, square root of 3 over 2. And tangent 30 degrees, opposite over adjacent, a over a root 3, which is 1 over the square root of 3. We could simplify this, get the root 3 out of the denominator. I'm just going to leave it there for now. So it's the sine, cosine, and tangent of 30 degrees. So just from using the 45, 45, 90 triangle and the 30, 60, 90 triangle, it enables us to write down the exact value of the trigonometric ratios for 45 degrees, for 60 degrees, for 30 degrees. And this gives an alternate method for solving problems involving those types of triangles. So for example, let's say I have a triangle like this. This is 30, 60, 90. There's the 30, there's a 90, so that must be 60. Let's say I want to solve this triangle. So I'll label it for trig. There's the hypotenuse. This must be adjacent. This is opposite. And now instead of using the triangle patterns as in the last lesson, I'm going to use the values for sine, cosine, tangent at 30 degrees, which are right, get this paper over here, right there. There's sine, cosine, tangent, 30 degrees. So let's get opposite first. I know adjacent, so I'm going to use tangent. Tangent 30 degrees is opposite, which I don't know, over adjacent, which is 20. Now in previous lessons we would look this up on the calculator. We'd get out the calculator, we'd say, okay, what's tangent 30, and type it in. Now we're going to use our table. Tangent 30, according to this table, is 1 over root 3. So that's opposite over 20. Then I multiply the 20 out of the denominator. And opposite is 20 divided by root 3. Or if you rationalize by multiplying the top and bottom by the square root of 3, it could be that. To get hypotenuse, I would use, I know adjacent and I want hypotenuse. So I'm going to use cosine. Cosine is adjacent, which I know to be 20, over hypotenuse. According to my table of values, cosine 30 degrees is the square root of 3 over 2. So I will cross multiply this. Get square root of 3 times hypotenuse equals 40. So the hypotenuse is 40 over root 3. Or if you rationalize, 40 square root of 3 over 3. So this provides an alternate method for solving problems involving 30, 60, 90, or 45, 45, 90 triangles.